So friends, let's ready to learn basic properties of electric charges. There are three basic properties of electric charges. They are: number one is said to be additivity. Number second is said to be conservation. And number third is said to be quantization. These are the three basic properties of charges. Number first property is additivity. This property says that charges can be added algebraically. Charges can be added algebraically. Let us understand this first property with some example. Example number 1. You are writing Q is equals to Q1 plus Q2 plus dot dot Qn if there are n number of charges. Example number 2. Q is equals to plus 7e minus 2e equals to plus 5e. This is a when plus and minus will be subtracted, the value of greater will be the answer. Q number third. Q is equals to minus 5e plus 2e, so you have minus 3. So charge can be positive or negative after addition or subtraction. This is said to be additivity or additive property of charges. Number second is conservation or law of conservation of charge. Law of conservation of charge. This property says that charge can neither be created nor destroyed, only transfer from one body to another body. Charge can neither be created nor destroyed, only transfer from one body to another. Let us understand this with an example. Suppose we have uranium 23592. This is bombarded with a slow moving neutron having mass 1 and charge 0. This is nuclear fission reaction. Then we know that two intermediate nuclei will be formed. They are barium 14156 plus krypton 9236 plus 3 neutrons 3n10 plus energy. Here you are saying that on the LHS side, charge on LHS side, that is before fusion, is equals to 0 plus 92, 0 plus 92, which is equals to 92. Charge on RHS side, that is after fusion, this is 56, this is 36, and here 0 into 3, 0 into 3. Again this come to be 92, 6 plus 6, 12, and 5 plus 3, 8 plus 1, 92. So LHS charge equals to RHS charge. This is also stated as that charge of an isolated system is conserved. Charge of an isolated system is conserved. Let us have another example. That is example of pair production of gamma radiation. So when gamma radiation will be subdivided into E minus plus E plus. This is metallization of gamma radiation also. Pair production, metallization of gamma radiation. So here gamma have 0 charge, 0 mass. Here this have charge minus, this is charge plus. So LHS side charge is equal to 0. RHS side charge is equals to minus 1 plus 1 equals to again 0. So this is said to be law of conservation of charge, the second property. Now third property is said to be quantization. Quantization means charge always occur in integral multiple of basic charge E. It never occur in fraction. This means that charge always occurs in integral multiple of charge E. It never occur in fraction. This is said to be quantization of charge. Here the formula is Q equals to plus minus NE, where you have E equals to 1.6 10 to the power minus 19 coulomb, and N is equals to 0 comma plus minus 1 comma plus minus 2 and so on. This is the formula, first formula. Let us use this formula for a question, numerical. Can a body have charge? Number A, minus 6.4 10 to the power minus 20 coulomb. Number B, minus 3.2 10 to the power minus 17 coulomb. Let us check it. Number A part, Q is equals to NE. The value of Q is given, which is minus 6.4 10 to the power minus 20 N, and the value of E is 1.6 10 to the power minus 19. So you have N is equals to minus 16 divided by 4 here, minus 19, and here it will be 10 to the power minus 1. So you have minus 4 by 10. It is fraction. So it is fraction. This means that Q naught equals to minus 6.4 10 to the power minus 20 coulomb. Let us see the second part. Q is equals to NE. Again, the value of Q is in this part minus 3.2 10 to the power minus 17. Value of E is 1.6 10 to the power minus 19. So when you cancel out, you get here 2. So you have N is equals to minus 2, and 10 to the power minus 19. When moved to this side, you have 10 to the power minus 17 plus 19 is equals to 10 to the power 2. So this means that you have 100 here. So this is integer. This means that Q is equals to minus 3.2 10 to the power minus 17 coulomb is possible. Let us have another numerical for you. Numerical number second. How many electrons are required to form 1 coulomb of charge? Let us see the solution of the numerical. You know that Q is equals to NE. So N is equals to Q upon E. The value of Q is 1 coulomb given, and the value of E is 1.6 10 to the power minus 19 coulomb. So this is 10 to the power 20 upon 16. This can be written as 10 into 10 into 10 4 times into 10 to the power 16, and this 16 is 2 into 2 into 2 into 2 4 times. 2 divided by this is 5, 2 divided by 10 5, 2 divided by 10 again 5, 2 divided by 10 again 5. 5 into 5 25, 5 into 5 25, 25 into 25 625 10 to the power 16, which you can write 6.25 10 to the power 18. Thus 6.25 10 to the power 18 number of electrons required to form 1 coulomb.